Chapter 3 midterm review is going to cover solving for variables in equations and then writing in function form. Okay, also it deals with some conversions. So the first 6 questions that we have are going to be solving for the indicated variable. Whatever variable's in the equation, that's what I'm trying to find. Remember, your answer should be as simplified as possible. For instance, x equals 2. It would never be something like 2x equals 4, because that does not tell me what x equals. It tells me that 2 times x equals 4, but I don't know exactly what x equals unless I solve it a little bit farther. So what I want to do in these problems is I want to simplify. In this first problem right here, what do you think I should do first? Madison?
Distributive property.
Distributive property. 4 times x is 4x. 4 times negative 9 is negative 36 equals 8. Now all I need to do is combine like terms so I can solve for x. What are my like terms? Darius? Negative 36 and 8. Can I just add them together like they are? No, we have to add 36 because that's the opposite. And now I have 4x is equal to 44. What would I do now to get x by itself? Divide by 4. And what does x equal? 11. In order to check that, all you would need to do was plug 11 and 4x into the original problem. So I would say 4 times 11 minus 9. I can plug that into my calculator and press enter. What I will get is 8. If that is the same number that I had in my original answer, I know I got my answer right. So you can move on from these problems knowing exactly if you got the right answer or not. Okay? Next problem. We want to do the same exact thing. I just want to solve for r this time. But I want you to pay attention because this can be tricky if you don't look carefully. What do I want to do first in this problem? Get the r by itself, which means I do?
Subtract 14.
Very good. Subtract 14. You say, wait a second, but it's a subtraction problem. Why wouldn't I add 14? Well, let's ask ourselves, is 14 positive or negative? Positive. So I have to do the opposite, which is negative, because I want it to say 14 minus 14 is 0. That's why it cancels out. But whatever I do to one side, I have to do to the other. And now I get negative r, because r doesn't just magically be by itself. There's still a negative in front of it. 3 minus 14 is negative 11. Now, what is in front of the r that I don't see but I know is there? Negative 1. So can I just say r equals negative 11? No. What do I need to do? Divide by negative 1. And what does r equal? 11. Again, you can plug that in and check. 14 minus 11? Yep, that equals 3, so I know I did it right. Last but not least, on this slide anyways, what should I do first? Distributive property. Negative 3 times negative x is positive 3x. Negative 3 times negative 4 is positive 12 equals 2x plus 1. This is where people say, I do not know what to do now. Well, it's actually just like the problem that you did first. All we want to do is combine like terms, but now I've got more than one like term. I've got the x's, which are like terms, and I've got the constants or numbers by themselves that are like terms. So I want to get the variables or the letters on one side and the constants on the other. That means I need to do what? Subtract 2x. What if you did not do that first? What if you subtracted 12 first? Would that be okay? What should I do now? Subtract 12. Subtract 12. I'm just doing this all in one step. Save time. 3 minus 2 is 1x equals 1 minus 12 is negative 11. This problem is a little different than the problem that we had before. Remember, what was the number in front of r? negative 1. So I did have to divide both sides by a negative 1 because remember, when we divide by a negative number, it just changes the sign. Well, a negative 1 anyways. It just changes the sign. So it does have an effect. But on this one, would I need to divide by a positive 1? No, because is it going to do anything? Negative 11 divided by positive 1 is still negative 11. So I can really just drop the 1 or make it a part of my box for my answer and say x equals negative 11. You could plug that in and check if you would like also. 3 more questions over solving for the variable. They go a little bit farther in difficulty. What would I do first here? Distributive property. Am I going to distribute the 3 to the negative x also? No, because it's not inside the parentheses. Only what is inside the parentheses is what I distribute to. So I have 8x plus 6 equals 12 minus 3x minus x. What's that number in front of x? 1. Go ahead and write it so we don't get confused. Now I'm at the step where I combine like terms. Do I have any like terms that are on the same side of the equation?
Yes.
Does that mean I need to add 1 so that I can combine it? No, because when they're on the same side of the equation, I do not have to change their signs. I leave them just like they are. So negative 3 minus 1 is negative 4. 8x plus 6 equals 12 minus 4x. Now is when I have to do the opposite because my like terms are on opposite sides. So I can add 4x to 8x. And I could subtract 6 and subtract 6 from 12. And I get 12x is equal to 6. What would I do now? Divide by 12. What is 6 divided by 12? 1/2. Make sure you remember that that is not 2. Because if you say it's 2, you're basically telling me 12 times 2 equals 6. Is that right? No. 12 times 2 is 24. All right, next problem. We go a little bit further in difficulty. What do you see that I have to do first? Distributive property. How many places do I have distributive property? 2. Let's go ahead and do both of those. 9 times b is 9b. 9 times negative 4 is negative 36. Minus 7b equals 15b minus 10. Again, I want to look for like terms and see if I have any on the same side of the equation first. Do I?
Yes.
Yes. What are they?
9b and negative 7b.
Do I need to add 7b so I can combine them? Nope. I just do them just like I see it. 9b minus 7b is 2b minus 36 equals 15b minus 10. What would I do now? Subtract 15b and add 36. So now 2b minus 15b is negative 13b. And negative 10 plus 36 is 26. Now I divide by negative 13. Perfect. And what does b equal? Negative 2. And last but not least in this problem here, this is the one that everyone's like, I don't know what to do. I'm so confused. It's actually one of our easiest problems. Because in order to get x by itself, I know that negative 1/5 and x are being multiplied. So the opposite would be division, right? But can I ever divide by a fraction? No. What do I do instead of dividing by a fraction?
Multiply the denominator.
Multiply by the reciprocal. Okay? So I want to do negative 5 over 1 because that's my reciprocal. And what happens is it totally cancels out and I'm left with an x only. But whatever I multiply on one side, I've got to multiply on the other side. Well, let's think about this. What is negative 5 over 1? Negative 5. So I can just do Negative 5. So negative 5 times negative 5 is?
Negative 25.
Positive 25. So 25 equals x is my answer. So the next two problems, which I've heard a lot of questions on the review sheet, are about the conversions. Now, some people are like, well, I know all you do is multiply. Not necessarily. Sometimes we're going to multiply and sometimes we're going to divide. Some people are able to say, yeah, oh, I know, I'm going to just multiply or I'm just going to divide. Right? But then some people mess up. They think they know what they're doing and they don't. So I can show you a way to always know whether to multiply or divide. And that is, we're always going to have two fractions. First fraction is always going to be exactly what they give you to begin with, what you start off with. In this first problem here, what do I start off with? 200 euros. And you always take what you have, and I'm going to put an E beside it so I know it's euros, and put it over 1. It will never be over any other number other than 1. Then I put my multiplication, because it doesn't necessarily tell me that I'm going to multiply. It's just going to set it up so I can see whether I multiply or divide. And this is what I have to do. This conversion right here is going to be the numerator and the denominator for my fraction. It just depends on which number goes where. Look at your first fraction. We had 200 what? Euros. So whatever is in the top of the first fraction has to be the denominator of the second fraction. So I know euros has to be on bottom in this conversion. So we've got 1 euro in the exchange rate. And then that means $1.066 has to be on top. And the reason why I do that is because what am I trying to get rid of? Euros. And I'm trying to end up with dollars. Well, guess what? I can cancel out my euros, and what's the only thing I'm left with? Dollars. That's the whole reason why you set it up like that. Well, this tells me, okay, 200 times 1.066. Remember, we always want to round to the nearest hundredth on these problems because we're dealing with money. And we should get 213.2. But since we're dealing with money, what am I going to add to the end of this problem? A 0, because it's $213.26. And the dollar sign is enough of a label because we know that US dollars always has that dollar sign. Just no other currency. Now the next problem. Let's look at the next problem here. We want to do the exact same thing. So what did I start off with? What do I have at the very beginning? 340 US dollars. What does that always go over? 1. Then I'm going to do my second fraction. I know my second fraction is going to be made up of this conversion, but what has to go on the bottom of this second fraction? US dollars. In the conversion, what is the number that goes with US dollars? 0.607. And 1 rand goes up top. So US dollars cancels out and I'm just left with rand. But what type of problem is this now? Division. Because see the numbers on the bottom? Does that make sense? So then we're going to do 340 divided by 0.607. Got a pretty large decimal number, so I want to round to the nearest hundredth, and I get 560.13 rand. And that is my answer. So see, that way, you always know, okay, I divide or I multiply. All right, last type of problem that we're going to go over in Chapter 3 is rewriting equations in function form. We're going to rewrite it so that y is a function of x. That means I have to have y where? At the beginning, and it's got to be by itself. Very good. So it's got to say y equals. This problem that I gave you is a little bit tricky because the problem on the midterm is a little bit tricky. You're going to have to do some work to get it in function form. There's two different ways that I can approach this problem. I can either say, all right, I'm going to distribute 1/2, And 1/2 is a pretty easy number to multiply by because I take whatever half of the number is that I'm multiplying, and that's my answer. Or you can say, I don't want to distribute the fraction. What could I do instead of multiplying by the fraction? Multiply by the reciprocal. So if I did that, it would be 2 over 1 and times 2 over here. Either method would get you the exact same answer. But for the sake of this problem, I'm actually just going to distribute the fraction because I think it's a little bit easier. What is 1/2 of 2? 1x. What's 1/2 of 8? 4y equals 8. So now I want to get y by itself. What do I need to start by moving?
Move the 1x over.
And how do I move it over?
Subtract it.
Subtract 1x. Very good. Does 1x go in front of the 8 or behind the 8? In front of. Very good, because the variable always has to be first. Negative 1x plus 8, because 8's positive. Now what do I do to get y by itself? Divide by 4. And I divide every single term by 4. And I get y is equal to negative 1/4 x plus 2. Very good. And now it is in function form. I have y by itself. That is the end of the Chapter 3 review.